Okay, so in this question, we talk about the calculations involved in thinking and braking distances. So the question reads that the car driver looks at lights and decides to stop, and there is this data given. So look at the graph. The car is coming at speed 30, and then after 1 second, it's stopping and it's decelerating all the way to zero. So take a note that it takes 4 seconds to stop and it takes 1 second at a constant speed. Mass of the car is also given, and you have to calculate these four things first of all. So the thinking distance. When the driver is at 0 seconds, the speed is 30. So until 1 second, he decides to stop. He thinks about stopping, and this at 1 second he applies the brake. So the distance is calculated in speed time graphs using the area under the curve. So you will be calculating just this area of this rectangle, and this will be 30 multiply 1. So it will be 30 meters. And then the braking distance will be the area under this triangle. So it is 30 and then 4 and then multiply with half. So that will be the braking distance. The deceleration of the car. So you will ideally take a gradient that gives you the acceleration. Remember the speed time graph, the gradient of the speed time graph gives you the acceleration. So if I were you, I would calculate the gradient of the whole because it's a straight line. So that gives me a very good, easy calculation. So the gradient is this triangle. So it will be starting from 30 to 0. So it will be 30 minus 0 and divide it with 4. That gives you the deceleration. Force. So the force will be calculated using the F is equal to ma. You are given m. You have just calculated the acceleration. So the force will be m multiplied a. The C part using using the idea about friction and deceleration, explain how the braking distance is affected. Well, if you have new tires, the braking distance will decrease because the new tires will give you good grip. The friction will be more, so the distance will decrease. So 2 marks for this. And the skidding on a wet road, the braking distance will increase 1 point, and then this is because there is less friction due to the wet road. The water between the tire and the road provides less friction. So these 2 points. Okay. And that's third point is car carrying a heavy load of passengers. So many students write that it will decrease the braking distance. No, it will not. It will actually increase the braking distance because the car with a lot of load has more inertia, so it requires more braking force. So with the same braking force, it will take more time and it will stop at a later. Okay, thank you.